Okay, so now we will discuss the equation of motions, which were the three equations of motion for uniformly accelerated motion. Uniformly accelerated motion means what? Acceleration of a body is constant. So the three equation of motion, which is v is equal to u plus at, s is equal to ut plus half of at square, and s is v square minus u square equals to 2as. These are the three equations of motion that we are going to derive now, and we'll see how will we derive. So over here we have to remember one condition, which is acceleration of the body is constant. Okay, so this will be our first condition. Acceleration of the body will be constant. So I'm erasing this now. Okay, so we'll derive all these three equations first. Fine. So we know acceleration is constant, which is a. Okay, so we'll use over here slight integration, so that in previous videos you have covered the differentiation and integration. Okay, so we know acceleration is constant, and we know, can we write this acceleration as dv by dt? Okay, so I'm writing this acceleration as dv by dt, which means rate of change of velocity is acceleration. Now we'll take that dt that side and dv this side. We know acceleration is constant, so we'll integrate it. Let's say at t is equal to 0, velocity of the particle is u, which means initial velocity of the particle is u and then the upper limit will be at any time t, velocity of particle is v. So over here I'll substitute the limit and I'll integrate this. So v limit will be 0 to v and it will be a t limit 0 to t. So from here I can write this limit is u, v minus u is equal to a t. So from here I can write v is equal to u plus a t. So this is our first equation of motion. V is equal to u plus at, where u is the initial velocity, a is the constant acceleration, and t is the time, and v is the velocity at any instant of time. Okay, so the second equation, now for second equation, can we write this v as dx by dt, because rate of change of displacement is the velocity. So v, which is u plus at, so I'll write this v as dx by dt, which is u plus at. Now again I'll take that dt that side, so dx is equal to u dt plus at dt. Again I'll substitute the limit. At t is equal to 0, let's say displacement is 0, at any time t displacement is s. So from here we'll substitute the limit x, the limit will be 0 to s. Over here if we'll integrate dt, so it will be u just t 0 to t, but over here it is t dt, so we have to integrate it by the power rule, which is power plus 1 upon power, so 1 plus 1 by 2, and the limit will be 0 to t. If I again simplify this, so s is equal to ut plus half of at square. So this is the second equation of motion. This was the first equation of motion. This is the second equation of motion. Now our task is to find the third equation of motion. So again for third equation of motion, what I will do is I will again take the initial condition, which is acceleration is constant. So acceleration is constant. I can write this acceleration is dv by dt is equal to a. Can I divide and multiply dx and dx? We can divide and multiply dx and dx. So over here if you will see dx by dt, if you see dx by dt is what? It's the velocity. So I can write this as v dv by dx is equal to acceleration. So v dv by dx, will take this dx that side, so dx. Again we'll substitute the limit. We know when the displacement is 0 and at t is equal to 0 the displacement is 0, and at that time initial velocity is u. So at t is equal to 0 displacement is 0, and so initial velocity is u, and at any time t displacement is s, and the final velocity is v. So from here if we'll integrate this, so v dv, integration of v dv is power plus 1 upon power, again power rule, so it will be v square by 2, and limit will be u to v, and over here it will be a s minus 0. So we'll take that 2 that side, so v square minus u square, if I'll substitute the limits, and then I'm taking this 2 that side, so 2a s. So this is the third equation of motion. So this is the derivation for all the three equation of motion. Now I'll just write the three equations again, and I'll just write what u A, T and V significances, just so that whenever you are solving problem, you should know what exactly U, A and V and T meaning is. So you just copy this and I'm erasing this. Fine. So these are the three equations of motion. So I'm rewriting the three equation of motion. So the first equation was V is equal to U plus AT. Second equation is S is equal to UT plus half of AT square. And the third equation is V square minus U square is equal to 2AS. So over here U is the initial velocity. Initial velocity means it is the velocity at t is equal to 0, which means let's say if it is in a problem, it is told a particle starts from rest, which means at t is equal to 0 its velocity is 0. And if it is told a particle starts moving with a speed of 10 meter per second, if particle starts moving with a speed of 10 meter per second, which means what, the initial velocity is 10 meter per second. Similarly v is the final velocity. Final velocity means after starting, let's say after 10 seconds, what will be the velocity? So that will be the final velocity at t is equal to t seconds, right? And t is the time taken to change its velocity from u to v. It is the time taken to change its velocity u to v. And a is the acceleration which must be constant. Means what? Uniform. Constant or uniform, because these equations we have derived by considering the acceleration of the body is constant. The acceleration of a body is uniform or constant. Acceleration, which means if it will be retardation, then we'll consider a as minus of a. Okay, fine. Now we'll solve few numerical based on these equations, and I'm just erasing this, and let's see how we will solve the questions. I'm erasing this entirely. So the very first question is, let's say Praveen starts running with speed 20 meter per second with a uniform acceleration 2 meter per second square. So the task is find the velocity of Praveen after 5 seconds, and also find its displacement after or in 5 seconds. Right? So I'm solving this question now. So first of all, I will write what are the values which is given to us. So given initial velocity of the object or of the person is how much? 20 meter per second. Acceleration is also given. Acceleration is 2 meter per second square, and time is given as 5 seconds. So we have three variables. So if we have three variables, then we can use those three equations of motion for finding everything whatever is asked in the question. So let's find first velocity, and the other variable is displacement. These two terms we have to find. So for finding these two terms, first of all, for finding velocity, we'll use equation v is equal to u plus at. So v is equal to u plus at. Initial velocity is what? Initial velocity is given as 20 plus at. Acceleration is 2 meter per second square, and time is 5 seconds. So the velocity will be 20 plus 10, which is 30 meter per second. So this is the first answer. Second part is asked in the same question, displacement. So for displacement, by using these three data, or we have fourth data as well now, so we can use any of the equations. So I am using this equation, s is equal to ut plus half of at square. So s is equal to ut plus, so displacement is equal to initial velocity is what? 20. So 20 into time is 5 seconds plus half of acceleration is given as 2 a t square, which means 5 square. So displacement is 5 into 2 will be 100 plus 25. So displacement is 125 meter. So these are the answer of the two questions. First one is velocity is 30 meter per second and displacement is 125 meter per second. Okay, so now I am erasing this question and I will give one more similar type of question. Okay. So again I am saying, if it is not mentioned in the question that in which direction particle is moving, so we'll automatically consider that it is starting from origin and moving along positive x-axis. Okay, until it is mentioned, we can consider that it is moving along x-axis. So the next question is, a person or a car starts with 40 meter per second with retardation 5 meter per second square. So find displacement in first 5 second. This is first part. Second part is its velocity after 5 second. So now this time initial velocity is given as 40 meter per second. I've started solving this question. You can also try by pausing the screen. Okay. So initial velocity is, because a car starts with 40 meter per second, which means this is initial velocity at t is equal to 0. Similar way, acceleration, this time it is given retardation, which means the acceleration of the body is continuously decreasing. So we will consider this as minus 5 meter per second square. This is initial velocity, this is acceleration. The third thing is given time. So time is 5 seconds. So we have to find again s and velocity. So the same formulas we can use again. Only difference is this time it is negative. So v is equal to u plus at. So v is equal to u is how much? 40 minus acceleration is 5 into time is how much? 5. So final velocity will be 40 minus 25, which is 15 meter per second, which means of course the velocity should decrease also. So initially the velocity was 40 second, but because of the car is deaccelerating, so its velocity is decreasing, which means initially it was faster and then its velocity became 15 meter per second. Similar way, the displacement. So displacement, again I'll use the formula s is equal to ut plus half of a t square. So s is ut, 40 into time is given as 5 second plus half of acceleration is given as minus 5 meter per second square. So minus 5 into time is 5 into 5. So displacement is 200 minus 125 by 2, which is 400 minus 125 by 2. So it will be how much? So then it will be 185 by 2, which is 92.5 meter. Okay. Sorry, 175. Yeah, which means you understood, right? So okay, so if I'll correct it, so it will be 87 meter. Okay. Now we'll solve one more problem based on this. Can I erase this? Okay. So this time the question is, a car was moving with 50 meter per second and suddenly driver applies brake and car stopped by traveling 20 meter. So again we have to find the retardation force that driver is applied, or retardation force or retardation of the car. So we have to find, first part is find retardation or deceleration, and second part is the time taken to stop the car. Fine. So again I will solve this question, you can also try along with me. Fine. So now it is given initial velocity, which means initially at t is equal to 0 the velocity of particle was how much? The velocity of car was how much? 50 meter per second, right? And the driver sees, the driver applies the brake and the car stops after traveling 20 meters. So the displacement is how much? 20 meter, right? And because the car after traveling 20 meters it stops, which means final velocity of the car will be 0, because after traveling 20 meters the car is stopped. So again we have 3 knowns. If once we have 3 known, we can find the other 2. So we have to find acceleration, and the second term is time. So again for finding acceleration, by seeing these 3 variables, which equation can be used? That is v square minus u square is equal to 2as. So v square minus u square is equal to 2as. So v square is how much? 0 square minus u square is how much? 50 square is equal to twice of acceleration is what we have to find, and displacement is 20. So from here we'll see it will be 2500 divided by 2 into 20 is the acceleration. So from here we can see the acceleration is also coming as negative 125. So minus of 125 by 2 meter per second square. So acceleration is coming as negative, so it should come negative, right? So if we'll take everything properly with sign convention, so the answer will automatically give the correct answer. So it should come 125 minus of 125 meter per second, right? Now the second part is we have to calculate the time taken to stop the car. Now we have acceleration, initial velocity, final velocity. So I'll use the equation v is equal to u plus at. So v is equal to u plus at. So final velocity is 0, initial velocity is how much? That is 50 minus at, acceleration is 125 by 2 into t. So from here time will be 50 into 2 by 125. So 25 2ja and 25 5ja. So it will be time is 4 by 5 seconds, because everything we have taken in standard units. So the answer will come 4 by 5 seconds. Okay. I think this is clear to you now. I am erasing this now. Now there is one more type of question, which is distance travelled in nth second. Distance travelled in nth second. Distance travelled in nth second means what? Distance travelled in third second or fourth second or fifth second. We know whatever we were calculating were the distance between time is equal to 0 to time is equal to 5 second or 10 second. But now our task is to find distance travelled in that fifth second itself, right? So if I talk about distance travelled in first second will be what? Distance travelled in first second minus distance travelled in 0 second. That will be the distance travelled in first second. Similar way, distance travelled in second will be what? Distance travelled in second minus distance travelled in first second. Similar way, distance travelled in third second will be what? Whatever will be the distance travelled in first 3 seconds minus distance travelled in first 2 seconds. That will be the distance travelled in third second. So similar way, distance travelled in nth second is what? Distance travelled in first n second minus distance travelled in first n minus 1 second. So this is what result we have to use, right? So I am erasing this. I hope you understood this, right? So let's say initial velocity of the particle is u, final velocity we are not sure, time is n, right? For the first case, time is n and acceleration is a. So if I talk about Sn, so Sn will be what? S is equal to u and time is t. Sorry, time we have taken n. So S is equal to u t plus half of a t square. So this is distance travelled in first n second. So now distance traveled in first n minus 1 second will be what? U s is equal to ut plus half of a n minus 1 t square, right? Now from both these two equations we can find distance traveled in nth second. Nth second is what? Distance traveled in s n second minus distance traveled in s n minus 1 second, right? So I'll substitute from these two equations the two values, okay? So s nth will be un plus half of a n square, and this is, I'll just multiply this inside, un minus u plus half of, I will use the equation a square plus b square minus 2ab, so n square plus 1 minus 2n, okay? I will again, if you see this un, sorry, it is minus basically, I've forgotten to put the minus sign over here, so it will be un plus half of a n square minus un plus u minus half of, again I am multiplying this term inside, so minus half of a plus half of a into 2n, okay? So I have simplified everything, which means half of a n square, half of a and half of 2 times a, but this minus had made this as negative, this also negative, and this is positive, right? If I'll simplify this again, so un will cancel out, and half of a n square and half of a n square cancel out. So the final formula for this will become as u plus half of, from this two term, half of a I am taking common, a by 2, and this is 2n minus 1, 2n minus 1. So distance traveled is in nth second is how much? Initial velocity u plus a by 2, 2n minus 1, okay? So this is the result. So over here you must have to remember that the initial velocity and acceleration and everything are positive, okay? So u plus half of a 2n minus 1, okay? So I'm erasing this again. This is also one of the important result, okay? I'm erasing this now. We will solve one problem based on this, right? A car starts from rest with acceleration 2 or 5 meter per second square. So find the distance traveled by the car in 10th second. So we just now had found distance traveled in the nth second is what? U plus a by 2, 2n minus 1, right? So initial velocity is how much? 5. Initial velocity, because it is told, starts from rest, so which means initial velocity is how much? What? Initial velocity is 0, acceleration is 5 meter per second square, and the nth second is how much? What? 10th second, which means n is equal to 10 second, right? So let's put these values over here. So distance traveled in nth second is 0 plus 5 by 2, 2 into 10 minus 1. So it is how much? 5 by 2 into 20 minus 1, that is 19, and then you simplify this distance traveled in nth second. So (95 by 2) 95 by 2 meters. So this is the answer. Understood? Now we'll solve more problem based on this. That is, the next topic is motion under gravity. Okay, fine.